Imagine standing in a casino, just looking up at this massive, seamless 4K video wall made of like a dozen different TVs.
Right, it's something you see all the time now.
Exactly. But if a single pixel is even a fraction of a millisecond late, that whole illusion just completely shatters.
It really does. I mean, we completely take for granted how difficult it is to actually split one fluid video across multiple screens like that.
Yeah, welcome to today's deep dive, where we are exploring the hidden tech that solves this absolute mathematical nightmare.
And we're using the WolfPack 4K 60Hz 3x25 HDMI Video Wall Processor as our guide today.
Which is quite a mouthful. But think of it like perfectly slicing a massive high-definition pizza across 12 plates.
Right.
So that, the toppings perfectly align without losing a single pepperoni in the process.
Yeah, that's a great way to picture it.
Okay, let's unpack this. Because the pizza analogy doesn't really capture the actual problem we're dealing with. Right?
Not quite, because TVs have physical frames, the bezels. So if you just slice an image perfectly, those bezels essentially act like thick black bars, just covering up vital parts of the picture.
Which would look weirdly disjointed to you, the viewer. So how does this processor actually trick our eyes into ignoring those plastic frames?
Well, what's fascinating here is how the software actively compensates for the physical world by actually throwing data away.
Wait, really? Just throwing it away?
Yeah, it uses what they call auto-adjust border and crop image functions.
Oh, I see.
So instead of squishing the image to fit inside those physical frames, the processor calculates the exact width of the TV bezels and digitally deletes the columns of pixels that would have naturally appeared behind them.
Wow, so it's intentionally creating a digital blind spot that matches the physical blind spot.
Exactly. And your brain just naturally fills in the gap.
Right, so it feels like you're looking through a paned window instead of, looking at a bunch of disconnected screens.
Precisely. You can even rotate images 180 degrees and use roaming windows to resize and place content anywhere.
That's wild.
And it's doing all of this with a 3840 by 2160 Ultra HD 4K image at 60 Hz.
And that 60 hertz part is the real hurdle, isn't it?
Oh, absolutely. It means the entire image updates 60 times every single second.
Right.
If one screen is even slightly out of sync with the others, you get what's called screen tearing.
Right.
Where like half of a moving object is a frame behind the rest of it.
And the source mentions this unit can perfectly push that data across 12 screens right out of the box.
Yeah, 12 screens.
But the software architecture actually supports up to a 3x25 configuration.
Which is 75 screens total.
75 screens. I mean, digitally cropping and perfectly syncing 60 frames a second across that many displays simultaneously must generate just a massive amount of heat.
It does, and that's exactly where the internal hardware has to be incredibly specialized.
Right.
The processor relies on DSP plus FPGA advanced image processing technology. FPGA stands for Field Programmable Gate Array.
Okay, so how is that different from like a normal computer chip?
Well, instead of a standard chip that runs software instructions step by step, an FPGA can physically rewire its own circuitry on the fly.
Oh, wow.
Yeah, it processes massive amounts of pixel data in parallel, which totally eliminates lag.
Here's where it gets really interesting. Because it's not just running a program, it's physically adapting its own hardware to route the data faster.
Exactly.
But doing billions of structural calculations a second usually means you need like a noisy, overheated server room to keep it from melting down, kind of like a high-end sports car engine redlining in a conference room.
Yeah, which is why the thermal design is so critical here. It uses an intelligent temperature control system paired with a silent smart fan.
So it monitors the heat in real time.
Right, and dynamically adjusts the cooling. So it survives in highly demanding 247 environments without sounding like a jet engine taking off in the corner of the room.
And because it runs so quietly and stays so cool, it dictates exactly where we see this technology popping up around you.
Definitely.
Because you don't need dedicated climate control.
Right, which explains why the specs specifically highlight setups in casinos, exhibition halls, and hotel lobbies.
Makes total sense.
But if we connect this to the bigger picture, this level of zero latency, synchronized processing isn't just for entertainment.
No, it's for intensely technical stuff too.
Yeah, we're talking about satellite positioning systems, GPS control rooms, and oil monitoring facilities where a split-second video delay could literally be disastrous.
Right, but here is my biggest takeaway from the source material.
What's that?
When you hear mission-critical FPGA hardware for oil monitoring, you naturally assume it costs like 50 grand.
Oh, easily.
But looking at the source, this specific WolfPack unit is $999.95. That completely upends the market.
It really does.
A local sports bar or a public high school can now afford the exact same industrial-grade processing power as a massive corporate control room.
Yeah, the barrier to entry for monumental, perfectly synced digital displays has essentially vanished.
It's crazy.
That complex math is now just commoditized inside an affordable, quiet little box.
So what does this all mean?
Well, the next time you walk past a giant, seamless video wall, you'll know exactly how much silent, mathematical heavy lifting is happening behind the scenes.
Right, it's not just a bunch of TVs plugged into a basic splitter.
No, not at all.
There is a specialized chip constantly rewiring its own physical pathways, deleting exact rows of pixels to hide the plastic frames, and flawlessly syncing the whole thing 60 times a second.
All to make sure you never actually notice the technology at all.
Which leaves you with this to think about. If a sub-$1,000 box can flawlessly map dynamic 4K video across 12 screens today, how long until the architectural spaces you walk into are just seamlessly stitched digital canvases reacting to your every move, like entire walls and ceilings?
That is definitely something to think about.